Okay, quadratic functions. You might see a quadratic function written in standard function notation. F of x is equal to ax squared plus bx plus c. Or you might see it written in standard form. F of x equals a times x minus h squared plus k. So if you have a quadratic function written in standard function form, then you can find the vertex by using the formula x is equal to negative b over 2a. If your function is written in standard form, then notice that this is written in the form that we use to graph a function given a transformation of functions. That you're shifting h units left or right and k units up or down so that the vertex is at the point hk. In either form, the parabola opens upwards when a is positive and downwards when a is negative. The graph of a quadratic function is called a parabola. So a parabola is a U-shaped curve. A parabola is a U-shaped curve. Could open up or down, could even open left or right, but the functions that we're going to look at are going to open up or down. So again, a parabola opens upwards when the value of a is positive, and it opens downwards when the value of a is negative. The vertical line that goes through the vertex is called the axis of symmetry. And the axis of symmetry is a line. If you're asked to find it, it's going to be in the form x equals, and then the x value of the vertex. The vertex is either the minimum point when the parabola opens upwards, or it's the maximum point for any parabola that opens downwards. Okay, so if we want to determine the equation given the graph of a parabola, probably the easiest way to determine this is, well, let's see, this is a parabola that opens upwards, so we know that the x squared term has to be positive. Okay, and only choice D has a negative x squared term. So on choice D, this is going to be a parabola that opens downwards, and it cannot be the graph that we're given here. And then you might use intercepts. The y-intercept is the easiest point to find. Here we know that the vertex is at 0, negative 4. And so if I substitute 0 into the function, my output should be negative 4. So going to choice A, if I substitute in 0, then my x squared becomes 0, and I get 0 plus 4, which gives me a point at 0, 4. So not the same parabola. So choice A is not correct. On choice B, when I substitute 0 in for x, my x squared term becomes 0, my x term becomes 0, and I get 16. So on function B, I'm going to have a y-intercept of 0, 16. Notice that on choice C, the only choice that we're left with, if you substitute 0 in for x, the x squared term cancels, and you're left with negative 4. 0, negative 4. So choice C is our function. Okay, so given a function, how do you find the vertex? Here we have f of x equals 2x squared plus 10x minus 12. Notice that by looking at this, we know the x squared term is positive, so this is going to be a parabola that opens upwards. And to find the vertex, we can use the formula x equals negative b over 2a. A is 2, b is 10. If we needed c, c would be negative 12. So substitute 10 in for b and 2 in for a. You get negative 10 over 2 times 2. 2 times 2 is 4. And negative 10 fourths reduces by 2 to give you negative 5 halves. Okay, so the x value of the vertex is at x equals negative 5 halves. To get the y value, you'd want to substitute in negative 5 halves for x. You can use your calculator to help you with this. Make sure that you use parentheses around the negative 5 halves. And because I don't have a calculator, I'm just going to work it out. Negative 5 halves squared is 25 fourths. Here on 10 times negative 5 halves, I multiplied 10 times negative 5 to get negative 50 halves. And because I saw that I was going to have a common denominator of 2, notice on the first term the 2 will cancel with the 4 to give you a 2. I rewrote 12 in fraction form. 12 over 1, if you multiply by 2 over 2, gives you 24 over 2. So now that we have a common denominator, you can just add numerators. 25 minus 50 minus 24 gives you negative 49 halves. So the vertex is at the point negative 5 halves, negative 49 halves. And again, we said the parabola opens upwards, so we know that the vertex is the minimum point. The minimum value is the output of the function, the y value. The minimum value is negative 49 halves when x equals negative 5 halves. Okay, so what is the vertex for the function f of x equals negative 4 times x minus 3 squared plus 6? Here we have the parabola written in vertex form. Notice that the value for a is negative. That means that your parabola opens downwards, and your vertex is going to be your maximum value. And here we can just pull out the value for the vertex, that we're shifting our graph 3 units to the right to a positive 3 and 6 units up to a positive 6. So the vertex is at the point 3, 6, and the maximum value is 6. Okay, we're going to find the vertex. The axis is symmetry, and then graph the parabola given f of x equals negative 2x squared plus 4x minus 1. So we'll start by finding the vertex using the formula x equals negative b over 2a. Okay, so in this case, a is negative 2, b is 4. So you get negative 4 over 2 times negative 2, or negative 4 over negative 4, which is 1. So x equals 1 is the x value for the vertex. To get the y value for the vertex, substitute 1 in to the function, and you get f of 1 equals negative 2 times 1 squared plus 4 times 1 minus 1. Do the exponent before you do the multiplication. You get negative 2 times 1 gives you negative 2, plus 4 times 1 is 4, minus 1. Negative 2 plus 4 is 2. 2 take away 1 is 1. So the vertex is at the point 1, 1. Bigger. Okay, we also know that this parabola opens downwards. Okay. So if we were asked to find the x-intercepts, we would know that there are two x-intercepts. This opens down, and it'll cross the x-axis at 2 points. The axis of symmetry is the imaginary vertical line that goes through the vertex. Let me just change this to a lighter color. And to show the imaginary vertical line, you would use a broken line. The equation for the axis of symmetry is x equals 1. Let me put that up here. X equals 1. Axis of symmetry, x is equal to 1. And then to graph the parabola, on my math lab, to graph a parabola, you need the vertex and at least one point. So the easiest point to find is the y-intercept when x is equal to 0. Substitute 0 in for x, and the x terms drop out. We're left with -1. So we get a point at 0, -1. Right here. And then by using symmetry, you can get this additional point at 2, -1. The line of symmetry says that your points are going to be symmetric with respect to that broken line. So going 1 unit to the left from the broken line and getting a y value of -1 tells you that if you go 1 unit to the right, you'll also get a y value at -1. This points at 2, -1. And your parabola will open downwards, something like this. To graph this on my math lab, you plot the vertex at 1, 1, and then I'll plot the point at 0, -1. Plot the point, choose your parabola tool, plot the vertex at 1, 1, and then at 0, -1, plot your second point, and you can submit it. Let's look at this application. We want to find the maximum area for 2 rectangular adjacent fenced playgrounds that are separated by a common fence. A total of 360 feet of fencing is used. Okay, so I have 2 rectangular adjacent fenced playgrounds. There's one, and there's another one, side by side, rectangular playgrounds, separated by a common fence. So let's let the width be represented by x. Notice we have 3 of those. And then the length is going to be the length all the way from one side of the first playground to the other side of the other playground. And we'll let that be represented by y. So we have y at the top and y at the bottom. So we're using a total of 360 feet of fencing, and that tells us that the perimeter, or if we add up all the distances, they should total 360 feet. So notice we have 3 x's and 2 y's. 3x plus 2y is equal to 360. I'm going to take this equation and solve it for y. By subtracting 360 from by subtracting 3x from both sides, and then dividing by 2. 360 divided by 2 is 180, and here 3 divided by 2, I just kept it as 3/2. So I get y is equal to -180 minus 3/2 x. Now what we want to find is the maximum area for the 2 playgrounds. And area of a rectangle is length times width. So our length here is y. It's all the way from one playground to the end of the other one. And the width is x. That gives you one entire huge rectangle, y times x. And then I'm going to substitute in the 180 minus 3 halves x for y so that I can get a function of one variable. So replace the y with 180 minus 3 halves x, and you get 180 minus 3 halves x times x, and then I'll distribute by the x to get 180x minus 3x squared over 2, or minus 3 halves x squared. Notice that we have a quadratic function. You have the x squared term with a negative coefficient. So if you were to graph this, you would have a parabola that opens downwards, and the maximum value would occur at the vertex. So to solve this problem, really all we have to do is find that vertex. So find the vertex using the formula x equals negative b over 2a. The value for b is 180. The value for a is negative 3 halves. So you get negative 180 over 2 times negative 3 halves. In the denominator here, the 2's will cancel, and you end up with negative 180 over negative 3, which is 60. So our vertex has an x value of 60, which means that when x is 60, you're going to have the maximum area. So here I'm going to take the 60 and substitute it in to get the value for y. So y is 180 minus 3 halves times 60. Notice that that 2 will cancel with the 60, goes in 30 times, and 3 times 30 is 90. So you get 180 minus 90, or 90 feet. So when y is equal to 90 and x is equal to 60, you have the maximum area. When x is 60 and y is 90, the area is y times x, where 60 times 90 is 5,400 square feet. And this is what we're asked for. Find the maximum area. 5,400 square feet is the answer.